In this video, we are going to look at what a convergent sequence is. So a convergent sequence is a sequence that goes towards a specific value as we go on. So as we go through the terms, it's going to tend towards a specific value. And this value is called the limiting value or the limit of the sequence. And it must be a finite value. So the limit of a sequence cannot be infinity because that is an infinite value. Any sequence that doesn't converge would be called a diverging sequence. Most of the sequences we have looked at diverge. So for example, if we take the sequence 3, then 8, then 13, then 18, and so on, so an arithmetic sequence, okay, we're adding 5 each time. So if we keep adding 5, we're just going to get bigger and bigger and bigger and bigger. We're not going towards one specific finite value, therefore this would be a diverging sequence. Now let's have a look at an example of a converging sequence. So we have an example of a converging sequence here. So 50, 25, 12.5 and so on. So it seems we're dividing by 2 each time or multiplying by a half. Okay, so this sequence is going to get smaller and smaller and smaller and smaller because we're multiplying by a half each time. However, there's no reason for the sequence to become negative because this number we're multiplying by is not negative, okay, it's a positive value. Therefore, if we're keeping getting smaller and smaller and smaller, but we're never going to get negative, then this sequence is going to converge towards 0. So we would say that the limit is equal to 0. Now, we'll never actually reach 0, okay, because if you keep multiplying by a half, you're never going to get to 0. If you need to get to 0 by multiplication, you'd have to multiply by 0. But that's okay, we'd still call it the limit, and what you'll find is for most sequences, they'll never actually reach their limit. Okay, they'll just get very close to it. And the reason in particular this one converges is because this half is a value between -1 and +1. That will be the case for your geometric sequences, if you want the value of the terms to get towards a specific value. So we have some sequences here, and you need to decide whether they're converging or diverging. So you might just want to pause the video and have a go. So if we have a look at the first one, okay, we've got 50.5 and 50.25 and 50.125. So the 50 is the same throughout. The thing that seems to be changing is the decimal places. So 0.5, then 0.25, 0.125. So it seems the decimal places are dividing by 2 each time. Now, one way of thinking about this sequence is we're doing 50 plus a smaller and smaller value each time. Now, that value seems to be halving that we're adding on. So therefore, that value is never going to become negative, so we're never going to dip below 50. We're never going to end up with 50 subtract a value. Okay, what this means is we're just going to get closer and closer to 50 as we go on. So therefore, this would be converging, and we would say that the limit of the sequence is equal to 50. Let's have a look at the next one. So we seem to be jumping between -1 and then +1 and so on. So that means we're jumping between 2 specific values. We're not going towards one specific value. So therefore, this would be a diverging sequence. Okay, even though we're not getting bigger and bigger and bigger or smaller and smaller and smaller in the negative direction. Okay, because we're not going towards one specific value, it's diverging. Let's have a look at the next one. So a half and a quarter and an eighth. It seems that we're multiplying by a half each time. Or another way of thinking about it is we're doing 1 divided by a bigger and bigger number each time. Okay, so in this scenario, if we're doing 1 divided by a bigger and bigger number, well then that calculation is going to go towards 0. Okay, we're never going to cross 0 because we're never going to divide by a negative number. But we are going to go towards 0, so it's going to be converging. And our limit in this case will be equal to 0. And once again in this scenario, we're not actually going to reach our limit, but that's fine. If we look at the next one, 4, 12, 36, and so on, it seems that we're multiplying by 3 each time. So we've got a geometric sequence. Because we're multiplying by 3, a number bigger than 1, okay, we're just going to keep getting bigger and bigger and bigger and bigger. So we're going to go towards positive infinity. So this is going to be diverging because we're not going towards a specific value. Let's look at the final one. So if we look at all my terms, the -9 is common throughout. The only thing that's changing is the decimal places, so 0.9, 0.99, 0.999. So it seems that the decimal places are getting bigger and bigger and bigger. So one way you could think about this is -9, subtract a larger and larger value each time. However, another way of thinking about it is -10 plus a smaller and smaller value each time. The first time it's plus 0.1, then it's negative 10 plus 0.01. So this value we're adding on is going to get smaller and smaller and smaller. We're dividing by 10 each time. However, these values, because we're dividing by 10 each time, are never going to reach 0. So therefore, the terms in the sequence are just going to get closer and closer to negative 10 because we're adding on a smaller value each time. Now, the value we're adding on is never going to reach 0, so we'll never actually reach negative 10, but that's fine. Okay, this is going to be converging, and we would say that the limit is going to be negative 10. Now, for most of these sequences, we're not reaching our limit ever. However, there are some sequences that do reach their limit. One basic example would be a constant sequence. Okay, for example, 3, then 3, then 3, then 3, and so on. Okay, because we've reached our limit, which is clearly 3, that one specific value we've ended up with.